The following is the video executive report of the C-130 UAV demonstration performed in March and April 2005 for the Undersecretary of Defense for Acquisition, Technology, and Logistics by the EPS Incorporated, Integrated Product Team of Snow Aviation International Incorporated, SAI, and SRDC Corporation. The team was contracted by the Army Space and Missile Defense Command in October 2004 to demonstrate the aerial launch and to attempt the aerial recovery of SRDC's Ultra Archangel by a C-130 mothership to determine the feasibility of airborne basing of unmanned aerial vehicles. In slightly over 6 months, and for $3 million, the EPS C-130 UAV Integrated Product Team designed and demonstrated repeatable UAV air launch techniques, verified the existence of an accessible launch and recovery envelope beneath the C-130, and set the stage for the fielding of an operational utility evaluation of UAV airbasing early in 2006. This video will document the design of 2 launch and recovery arms, the tailoring of a successful UAV design for airborne launch and recovery, and the integrated flight demonstration of the Ultra Archangel and its C-130 mothership. SAI first documented the direction of airflows at various distances off the C-130's ramp, as the manipulator boom and UAV would have to transit that turbulent zone to reach undisturbed flow below the belly of the C-130. To mitigate technical risk and protect schedule, SAI chose a 2-track approach to manipulator arm development, one developed in-house at SAI and one outsourced to Laboratory Enterprises. The Laboratory Enterprises version's use of an enclosed docking module required assessment of airflow downstream of the module. This assessment was accomplished using full-scale models mounted on a pickup truck and showed the docking module's wake turbulence to be symmetrical and benign. Fabrication of the Laboratory Enterprises arm was started first, and its assembly and checkout were begun in the SAI hangar in Columbus at the end of January 2005. The boom was mounted on SAI's high-lift cargo loader to facilitate full range of manipulator arm motion actuation. Although started later, the SAI boom fabrication was also completed at the end of January, and it too was assembled and checked out on the cargo loader. Ground testing of the Laboratory Enterprises boom through its full range of motion continued, with the Ultra Archangel aerodynamic shape loaded to replicate the full flight weight and twice the calculated launch airspeed drag of the free flight vehicle. These tests identified the need for additional design refinements for accomplishment prior to on-aircraft ground and captive flight testing. Fully loaded Ultra Archangel capability with and retention against twice the expected flight drag loading were then verified with the SAI boom. These tests identified the need for further design refinements prior to C-130 ground and captive flight testing to make the boom more robust. SAI at this time decided against down-selecting and elected to continue the parallel boom developments into the flight trials. Meanwhile, SRDC's separate adaptation of its Archangel UAV for carriage and air launch from the C-130 was exploring small camera placements on the UAV, video links from the Ultra Archangel that would superimpose pitch ladder, roll reference, and other heads-up display symbology, and a virtual reality display to give the pilot a UAV eye view of the final approach to the C-130 and docking. The 1-watt S-band signal strength used proved too weak to provide reliability and useful range. So, these innovations were not used in flight during this demonstration. The SRDC provided aerodynamic captive carry shape was secured into the Laboratory Enterprises manipulator arm and forced through the turbulent boundary layer right behind the open C-130 ramp in flight trials in Ohio. The turbulence noted in these transits resulted in an SAI decision to reduce the power on the C-130's inboard engines during the subsequent flight series over the Florida Everglades. The fully extended Laboratory Enterprises boom attained undisturbed and non-turbulent airflow just 3 feet below the belly of the C-130, validating the concept of using the manipulator arm to force the Ultra Archangel through the turbulent airflow around the C-130's aft fuselage to reach a more benevolent launch and recovery envelope. The forward retraction path of the Laboratory Enterprises boom resulted in tight clearances on the edge of the ramp and in high stresses on the actuator support structure, and a long cantilevered extension of the overhead support structure through the retraction was uneventful during the Ohio captive carry tests. The SAI boom's extension path took the UAV through the turbulence layer 7 feet further aft than had the arc of the Laboratory Enterprises arm. The captive carry shape manifested there a stronger left roll tendency, which was attributed to more powerful swirl turbulence from the left inboard engine impinging on the C-130's aft left fuselage. The C-130 was flown between 120 knots and 110 knots, indicated airspeed, for all UAV operations outside the cargo compartment. The fully depressed SAI boom placed the captive carry shape 7 feet below the belly of the C-130, offering greater latitude in UAV approach paths to the docking module. A pendulum effect was noted in turns with the SAI boom fully extended. These captive carry trials resulted in a decision to minimize roll rates and to use bank angles no greater than 10 degrees with the manipulator arm extended. Retraction of the SAI boom, which included mechanical linkages for keeping the UAV aligned with the relative wind throughout the transit, was smoother than that of the Laboratory Enterprises boom, and was facilitated rather than opposed by air loading. In separate testing from Dade Collier Airport in the Florida Everglades, the Ultra Archangel avionics flew in a Taylor-Craft radio-controlled model, which crashed when a radio control lapse resulted in undetected reversion to the L-band control mode. The full Ultra Archangel then flew for the first time from a car-top launch, with only the SRDC developed L-band control system and with the S-band video camera link operating. Roll control on this flight proved oversensitive, with the UAV going through a series of excursions prior to loss of control and a crash that extensively damaged the vehicle. SRDC reduced the aileron span by 30% when it rebuilt the UAV after this flight, which was the last until the air launch from the C-130. The C-130 mothership deployed to Kendall Tamiami Airport on the outskirts of Miami in March for joint flight operations with the Ultra Archangel. Pre-flight ground testing included engine-running electromagnetic interference checks and ground antenna pattern checks with the UAV moved around the parked C-130. The Ultra Archangel was loaded in a partially extended Laboratory Enterprises boom docking module. Its engine started, and it was retracted into the C-130 cargo compartment in a ground mission rehearsal for the mission crew. This was the first combination of the free flight weighed and configured Ultra Archangel with one of the manipulator booms. The C-130 mothership launched for an antenna coverage and range measurement flight over a ground party pre-positioned at the Dade Collier Airport, 28 miles from the Kendall Tamiami deployment base. During the extension of the Laboratory Enterprises boom into the airstream without the Ultra Archangel, the overhead boom structure failed, necessitating the previously practiced cargo winch retraction of the boom, which had jammed in the extended position. At this point, program management elected not to repair the failed boom, but to continue tests only with the SAI boom. The boom antenna and transmitter array was moved to the SAI boom, which then was exercised through the same ground electromagnetic interference, antenna pattern, and UAV engine running retraction tests as for the first boom. As the last pre-flight rehearsal, the mission crew practiced a last resort manual retraction of the SAI boom with simulated multiple failures of the boom actuator and the aircraft cargo winch. The C-130 then attempted to launch for an antenna coverage and transmitter range evaluation flight over Dade Collier, but a C-130 propeller maintenance problem forced a ground abort, and a 3-week delay for a replacement propeller. The first flight after the propeller replacement was to exercise the SAI boom with a flight-weighted but inert Ultra Archangel shape. During the first in-flight extension of the UAV secured into the docking module, both Ultra Archangel winglets failed, and the UAV was retracted, and the mission was air aborted. SRDC redesigned and fabricated the winglets overnight for the next day's flights. SRDC, during the C-130's maintenance delay, lost the services of one of its UAV pilots and decided to attempt control of the Ultra Archangel solely from the ground at Dade Collier, since a pilot had to be on the ground for a ground landing if the UAV could not be docked in flight. Therefore, SAI personnel were trained to start the Ultra Archangel's engines in a series of drills on the ground at Tamayami. The first captive carry flight of an engine running in full-up Ultra Archangel overflew Dade Collier and extended the manipulator arm with the UAV strapped in for captive carry power sufficiency evaluations designed to determine the UAV's drag-nulling power setting. However, the UAV's engine seized due to coolant pump's loss of power from exhausted batteries. The UAV was retracted, removed from the boom, and the antenna coverage and pattern evaluation was conducted after extension of the empty boom. It was determined that the video link to the ground was very weak, with less than 1 mile range. The L-band flight control range could not be evaluated with the UAV inside the C-130. SRDC personnel removed, replaced, and ground tested a new engine overnight, as well as devising procedures to preclude battery power exhaustion during future trials. The consequence of the very short S-band video range was that the Ultra Archangel could not be air-launched from the C-130 and flown from the ground. SRDC persuaded its former pilot to rejoin the program for the 26th of April and reattached its full antenna and transmitter array to the SAI boom. The power sufficiency checks, lost when the earlier engine seized, were repeated with the UAV loosely strapped to the docking module to evaluate retention. The drag balancing power setting was determined to be approximately 82%. After removal of straps, the Ultra Archangel was successfully extended, with its engine running through the turbulence layer into the launch envelope, with no slippage in the docking module. During this extension, it was noticed that one of the 2 cylinder head coolant loops was not working. The manipulator arm was retracted, again without Ultra Archangel slippage in the docking module, as it transited the turbulence zone, and the door and ramp closed for inspection of the cooling system. SRDC personnel troubleshot the UAV's cooling system and determined that it was operating normally. The door and ramp were reopened and the Ultra Archangel positioned in the launch envelope for the stepped relaxation of clamping forces to evaluate UAV control response prior to free flight. During this relaxation, the UAV began an oscillation, which became divergent after the SRDC pilot applied maximum power, and Ultra Archangel launched during a downward excursion. The excessive forces generated in the oscillations, over twice the design loads for the SAI boom, caused a material failure in the boom actuator bracket. Even with these anomalies, the EPS-IPT demonstrated that the SAI boom could, 1. Traverse the SDRS UAV with engine running through the turbulent layer with no damage to the reinforced winglets, the engine, or the structure of the UAV. 2. Stabilize the UAV in benign air 7 feet below the C-130 mothership. And 3. Launch the UAV and provide a suitable basket to recover a UAV in flight. The SRDC pilot recovered the UAV from the dive and brought it back up to the level with the C-130, but the Ultra Archangel had dissipated its airspeed in the excursions and did not exhibit sufficient excess thrust to accelerate back to the C-130's airspeed. It fell further behind the C-130, and when it was about a mile back, ceased responding to pilot inputs. It crashed near the Dade Collier Airport and was recovered on 28 April for assessment, which continues. The most likely causes of the divergent oscillations were the interaction of the elasticity of deliberately opening the clamping arms slowly, combined with the pilot's application of full power, and the resulting increased gyroscopic pitch effects of the prop and engine. Both of these causes have operational and procedural solutions, retarding the throttle settings slightly while simultaneously rapidly opening the clamping arms. The C-130 UAV program successes of the first half of this list provide the foundation for a future operational capacity using the solutions presented in the last 5 items. UAV aerial launch and recovery, airborne control, and sensor monitoring building blocks are now in place for an operational utility evaluation at the end of the next demonstration series and early in 2006. The successes of the C-130 UAV program can be exploited and current momentum sustained to attain a capability for an operational utility evaluation in the United States by early 2006.